Welcome to YQ Academy, SQL, Interview Questions and Answers. 1. What are defaults? Is there a column to which a default can't be bound? In SQL, a default is a predefined value that is automatically assigned to a column when no explicit value is provided during an insert operation. It ensures that a column has a value even if one is not explicitly specified in the insert statement. The default value can be specified when creating the table or added / modified later using an alter table statement. The default value can be a constant value, e.g., a specific number or string, or system-generated value, e.g., current timestamp. Regarding your second question, a default value can be bound to most types of columns, including numeric, string, date/time, and even user-defined types. However, there is one column type to which a default value cannot be directly bound, and that is the blob binary large object or text column type. Blob and text columns store large binary or text data, respectively, and their values cannot be set to a default value directly. This is because these column types typically require specific data input methods such as inserting a file or text block and do not have a defined default representation. If you need to provide a default value for a column that requires large binary or text data, you may need to use a workaround, such as using a nullable column in conjunction with a trigger or application logic to handle the default value assignment. In summary, while defaults can be bound to most column types in SQL, blob and text columns cannot have direct default value assignments due to their nature of storing large binary or text data. 2. Explain different isolation levels. In SQL, isolation levels define the level of data isolation and concurrency control in a database transaction. Different isolation levels provide different trade-offs between data consistency and transaction concurrency. Here are the commonly used isolation levels. 1. Read uncommitted. This is the lowest isolation level where transactions are not required to wait for other transactions to release locks on the accessed data. Transactions at this level may read data that has been modified by other uncommitted transactions, leading to dirty reads, non-repeatable reads, and phantom reads. This isolation level provides maximum concurrency but sacrifices data consistency. 2. Read committed. This isolation level ensures that a transaction only reads committed data. It prevents dirty reads by waiting for a lock on a data item to be released by another transaction before reading it. However, it does not prevent non-repeatable reads and phantom reads, as other transactions can modify or insert data between consecutive reads. Read committed provides a balance between concurrency and data consistency. 3. Repeatable read. In this isolation level, a transaction obtains shared locks on all data read during the transaction, ensuring that other transactions cannot modify the same data until the transaction completes. It prevents dirty reads and non-repeatable reads but allows phantom reads. However, it guarantees that within the same transaction, the result set remains consistent. This level is suitable when long-running transactions need consistent data during their execution. 4. Serializable. This is the highest isolation level, providing the strictest form of data consistency. Serializable guarantees that concurrent transactions do not affect each other, preventing dirty reads, non-repeatable reads, and phantom reads. It achieves this by placing shared locks on all data read during a transaction, preventing other transactions from modifying the same data. Serializable isolation level ensures maximum data consistency but may result in reduced concurrency and increased contention. 3. What's the maximum size of a row? The maximum size of a row in a database table depends on the database system you are using and its specific configuration. However, there are some common factors that can affect the maximum row size. 1. Page size. Most database systems store data in pages, which are fixed-size blocks of disk space. The maximum row size cannot exceed the page size, as a row should fit within a single page. The page size can vary across different database systems and configurations. Common page sizes are 4 KB, 8 KB, or 16 KB. 2. Column sizes. The size of individual columns within a row contributes to the overall row size. Each column has a defined data type and length, which determines how much space it occupies in a row. For example, a column defined as var_caroni 100 will take more space than a column defined as int. 3. Variable length columns. Some columns, such as varchar, var_binary, or text, can store variable length data. The actual amount of space they occupy in a row depends on the actual data stored in each row. If a row has long values in variable length columns, it will occupy more space. 4. Overhead. Database systems typically have overhead for metadata and bookkeeping information associated with each row, such as row pointers, column offsets, and control information. This overhead contributes to the overall row size. 4. Explain active/active and active/passive cluster configurations. 1. Active/active cluster. In an active/active cluster configuration, multiple nodes or servers in the cluster actively handle client requests and share the workload. Each node is independently processing requests and performing tasks simultaneously. This configuration allows for better utilization of resources across the cluster and can provide higher scalability and performance. If one node fails or becomes unavailable, the remaining nodes continue to handle the workload. The client requests are typically distributed across the active nodes using load balancing techniques. 2. Active/passive cluster. In an active/passive cluster configuration, one node or server in the cluster known as the active node actively handles client requests, while the other nodes known as passive nodes remain in a standby or idle state. The active node processes all incoming requests and performs the necessary operations. If the active node fails or becomes unavailable, one of the passive nodes takes over its role and becomes the new active node. This configuration provides failover capability, ensuring that client requests can still be processed even if the active node fails. The failover process typically involves detecting the failure and automatically switching the workload to a passive node. 5. Explain the architecture of SQL Server. 1. Client application. The client application is any software or program that interacts with SQL Server to send queries, retrieve data, and perform database operations. Examples of client applications include desktop applications, web applications, and command line tools. 2. SQL Server Instance. A SQL Server instance is a standalone installation of the SQL Server software running on a server machine. It represents a separate, isolated database environment. Each instance has its own set of databases, configuration settings, and system resources. 3. Database. A database in SQL Server is a container that holds a collection of related objects, such as tables, views, stored procedures, and indexes. It is the fundamental unit for organizing and managing data. SQL Server instance can host multiple databases. 4. SQL Server Engine. The SQL Server Engine, also known as the database engine, is the core component responsible for processing and managing database operations. It includes several subcomponents. A. Query processor. The query processor analyzes and optimizes the SQL queries received from client applications, determines the most efficient execution plan, and generates the result set. B. Storage engine. The storage engine manages the storage and retrieval of data on disk. It handles tasks such as data file management, buffer cache, transaction management, and locking mechanisms to ensure data integrity and concurrency control. C. Buffer pool. The buffer pool is a portion of memory used to cache frequently accessed data pages from the disk. It helps improve performance by reducing disk I/O and providing faster access to data. D. Lock manager. The lock manager controls and manages locks to ensure data consistency and concurrency control. It handles requests for shared locks, exclusive locks, and manages transaction isolation levels. E. Log manager. The log manager records all database modifications in a transaction log file. It maintains a sequential record of all changes, allowing for crash recovery, transaction rollback, and replication. 5. The SQL Server Agent. The SQL Server Agent is a service responsible for scheduling and executing automated tasks within SQL Server. It can be used to schedule jobs, such as backups, database maintenance, or data import/export operations. 6. Management Tools. SQL Server provides various management tools to administer and monitor database operations. Examples include SQL Server Management Studio SSMS, SQL Server Configuration Manager, and SQL Server Profiler. These tools allow administrators to configure server settings, manage security, create and modify databases, and monitor performance. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.